Greetings and welcome. We've been talking about normal distribution. We're on page 923, taking a look at the homework. And problem 9 says the mean of a set of normally distributed data. All right, this is key, actually. Sometimes books seem to have the tendency where they'll teach you a skill, and then coincidentally, all of the problems happen to start matching that skill. So I just want to point out that not all data in the real world is normally distributed. Obviously, in this section of the book, they'd want to give you those kinds of problems merely so that you can practice the new skill you learned. But it occurs frequently, but not all the time. Let's see. So the mean is 12, and the standard deviation is 1.5. So part A says sketch a curve that represents the frequency distribution. So let's see. Wow, look at that sketch. I'm amazing at this. Wow, that's so good. So let's see. What did I know? I knew that the mean was 12. So let me label this. I'll label this 12 here. Right, would have been my mean sort of concept right there. And if the standard deviation, this would be one standard deviation away. This is what that 1, 2, and 3 mean. But let's label our axis in terms of units. If the standard deviation is 1.5, then this would have been 13.5. This would have been 15, right? And then 16.5 over here. And over here, subtract 1.5. This would be 10.5. I believe this would be 9. And I think this would be 7.5 in terms of units of whatever our data is measuring. Okay? So there's part A. There's our sketch. Actually, I might even snapshot a snapshot. That's right. Here we go. So that way I'll be able to have mine labeled. Here we are. Then it says B, name the interval about the mean in which 68.3% of the data are located. So it uses the phrase about the mean. So P is equal to 68.3%. The fact that it's about the mean, do you think I'm looking for a t value or a z value? T value is about the mean. So that's what we're looking for, is what t value gives me 68.3% of the data. Now it turns out, we'll be able to look that up on our chart, but it turns out 68.3% of the data is up 1 standard deviation and below 1 standard deviation about the mean. So this is the region that it would end up being. But let's actually, in case we didn't have that memorized, let's show how we would find that on our little chart that we had. So, well, this table over here is if you know the t value, find the p value. This table is if you know the z value, find the p value. And this table over here is if you know the p value, find the t or its z value, is kind of how I laid this out. Now in this case, the p values, looking it up on this table, it doesn't line up exactly right. So you could have estimated, well, maybe it's around 0.93. Or, in this case, 68.3%, we actually is a common one that occurs at exactly 1 standard deviation. So that's what I would have been referring to here is this guy. So 1 standard deviation above and below the mean gives me 68.3% of the data is the idea. So that's how I would have looked up my t value on my table, and then I would have graphed it above 1 standard deviation, below 1 standard deviation. So t is equal to 1. And to explicitly answer the question, they asked not what the t value was, they wanted the interval. So they want that in terms of units. So I would say between 10.5 and 13.5. All right, is where 68.3% of our data exists. All right, so that's the idea for that. Let's see. So part C. Here we go. Let's see, it says what percent of the data is between 7.5 and 16.5. I think that might not even land on my chart. Oh no, it does. It does. So, well, looking at this, 7.5 is right here, 16.5 is right here. That's going to look like my whole chart. It's not all of the data though, it's just most of it. All right, there we go. And we're talking about 3 standard deviations above and 3 standard deviations below. Okay, so in this case, 16.5, if I wanted to figure out how many standard deviations that was, I could subtract the mean and then divide by sigma. All right. In this case, I happen to know it's exactly 3 because I already kind of calculated that. But 16.5 minus 12 divided by 1.5, I just want to verify for you that this works out. 16.5 minus 12, what's that going to be, 4.5? Yeah. Yep. And 4.5 divided by 1.5 is going to be 3. So 3 standard deviations above the mean is what that 3 is, okay? So I just want to point that out because it doesn't always land exactly on one of these nice standard deviation tick marks all the time. And then the same thing is true for that, so 7.5. I could have done 7.5 minus x bar over sigma and gotten 7.5 minus 12 over 1.5, and I would have gotten negative 4.5 over 1.5. And I would have realized that that's 3 standard deviations below the mean. All right? So I'm talking about the same amount above and below since it's an about the mean situation. I'm looking for the t-value, 3, and I want to find the percentage corresponding to that t-value. Okay? So you might memorize that value at some point, but assuming we didn't, well, I know it's a t-value and I'm looking for a p-value, so I'm going to scroll down here and I find that at 3 standard deviations above and below the mean, the corresponding t-value or p percentage is 99.7%. So that would be my answer. 99.7% of the data is within that region, okay? So that certainly is a lot of the data. Not all of it, though. Now, I guess I could phrase the question in terms of kind of the opposite of it. What if I said, what percent of the data is less than 7.5 or greater than 16.5? And that would just be the 0.3% remaining, right? Because 100% of the data is under this curve. So if I just subtract this, that would give me the corresponding little slivers over here and here, 0.3%, right? So not a lot of that is there. Let's see. And question D, what percent of the data is between 9 and 15? Well, this one's not too tricky. Similarly, this one happens to land exactly on the tick marks, but they're starting us off, warming us up, 9 and 15. And it happens to be the same amount above and below, right? So you might be able to see that's 2 standard deviations above, 2 standard deviations below. So just writing down everything I know, I would say, well, t is equal to 2, so I'm finding the corresponding p-value, and that's going to be 95.4% of the data, right? So 95.4%. So that's kind of how you work with that graph as well as the chart. So the key is making sure you kind of first draw your picture well, and kind of label your axes and know how many a standard deviation is above and below. So let's take a look at a trickier problem. Here's problem 13. It says that a set of data is normally distributed with a mean of 140 and a standard deviation of 20. What percent of the data is between 100 and 150? Well, let me grab a nice little, not there yet. I want to grab this. Aha. Fortunately, the curve is pretty much identical every time. The only thing that's changing is my scale. So, let's see, let's draw this. So if the mean is 140 and the standard deviation is 20, that means 1 standard deviation above is 160, 2 is 180, 3 is 200. -1 is -120, then 180 over here, right? So all I've done is either add 20s or subtract 20s from the mean to get kind of my corresponding value. Let me just get a nice snapshot of this, since I'm going to use this multiple times, I imagine. So let's see, they ask, what percent of the data is between 100 and 150? Now 100 is nice, that lands right on a standard deviation tick mark, but 150 is not so nice. So this is what we're referring to, and now the problem is, it is kind of it's an about the mean problem, but it's not exactly the same amount on both sides. And the problem is we also have to figure out how many standard deviations is this, right? So to figure that out, let's figure out that value first, that corresponding t-value. So I would do 150 minus the mean divided by what a standard deviation is. Okay, so that's going to be 10 over 20. So 150 occurs at 0.5 standard deviations. All right, so that's no longer units, that's in terms of standard deviations. So this is 0.5 above. I think you guys realize already that this is 2 below, right? So I'm looking for between -2 and 0.5 above. Now, there's a couple ways I could do this. Let me actually draw a couple pictures here. I could think of this as these two. I think I could do this using t-values or z-values. If I want to use t-values, I could look at the 2 below and 2 above situation and cut this in half. So this would be half of the percent when t is equal to 2. All right, and then for the half above and below, I could actually just figure out what the 0.5 above, 0.5 below is, and then divide that in half, because I don't want above and below, I would just want half of its value. So half of when t is equal to 0.5. And if I add those together, I'd get this part plus this part equals the big part up there, right? So that's one way you could do it. Let's actually just look up those corresponding values real quick. Let's see, so this is going to be half of t equals 2 gives me, what percent? 0.954 or 95.4. I'll write it in terms of percentages. Plus half of 0.5 of a standard deviation. So that's 0.383 or 38.3%. Right? So let's do 0.5 times 95.4. This is 47.7 plus 0.5 times 38.3, and that's 19.51. 51 or 15? 15, sorry. And add those together, 47.7. And I get 66.85% of the data is between those two zones there. Okay? So, and that is what they had as well, right? Now, the other way I could have done this, instead of using t-values, I could have done it using z-values and subtraction. And you don't have to do both. I'm only showing you both for mainly educational purposes, so that way you can, maybe you perceive it one way more than the other, right? Maybe that's the case. So if I want to do subtraction between these two things, actually let me, there. I don't know if that's any better. If I want to do subtraction between these two things, then I'm going to have to do big area minus little area, okay, in order to get a positive number. So I want to do big area, and z-values give me a value below which a certain percent lies, right? So I'm gonna find this whole amount, so 0.5 above, and all the way down to negative infinity standard deviations below the mean concept, right? And I'll subtract this z-value, the -2 below. And you guys see that if I subtract the little area from the big area, it's going to give me the zone that I'm talking about. Right? So it's the same exact problem, just a different way to perceive it. So in this case, this would be when z is equal to 0.5. This would be when z is equal to -2, I believe, or 2 standard deviations below the mean. And let's see if I can look those up. I think I have. Ooh, we might have to. This one we might have to do some clever work on. We'll see. So 0.5 above. Well, I'm looking at z values here. So 0.5 above is 0.6914. Is that right? Yeah, because it's greater than half. So 69.15%. And let's see, that's less than our answer, right? So I'm expecting this one to be somewhere around 2-ish%. And let's see, z equals -2. Now, you might realize I don't actually have z equals -2 here, is the problem. So what's a solution we could do to find z equals -2? Because these z values are always all above the mean. Yeah, do 100% minus this would give me that amount, right? The other spot I could kind of look it up almost if it landed there perfectly. I could see that a z value of -2.05 gives me about 2%. All right, but we can do it a little bit more accurately than that using this over here. So 0.977 or 97.7%. I'm going to do this. Consider this 100 minus 97.7%. All right, so that's going to be minus 2.3%. Loop-de-2. Yeah, definitely. And hopefully this all works out. And I get 66.85%. So I do in fact get the same value both ways. So in this case I would say probably the z value was the easier way to do it because I didn't have to divide my percentages in half. Well, I guess this had that additional little subtlety right there. But same problem, thought of 2 different ways. One was Boolean addition, one was Boolean subtraction to find the remaining area. Let's see. Between 150 and 180. Let's see if I can do this one quickly. Between 150 and 180. I'm going to shrink this down just a little bit because I might run out of room. So 150 is my, I already know where that is, and 180. So this is what I'm looking for. And what are your guys' thoughts as far as setting this up? Because this is 0.5 standard deviations, and this is 2 standard deviations. You want to use z values or t values? T? Okay. Yeah, that's true. I could have done that. So t value, I could look up. A t value would give me 2 above and 2 below, right? So what would we have to do that t value? Because I don't want the below part necessarily. I would have to half it. All right, just to get this piece. Is that what you guys were thinking?
Yeah,
and then a half of this piece. So to describe this, this is half of t equals 2, and this is half of t equals 0.5. And what am I going to do? Am I going to add or subtract these? Subtract them, right? You guys agree? If it was 0.5 below that I was looking for, then I would have added those, is what I would have done. But it wasn't. So so that's if I did the the t-value approach. So let's just do this real quick. It looks like, yeah, I'm almost out of room here. So t equals 2. Half of that is going to be 0.954. We calculated that earlier, I think. 95.4 minus half of t equals 0.5 is 38.3. So let's see, so 0.5 times 95.4 minus 0.5 times 38.3, and I get 28.55. There's another loop-de-two. Right, so I'm able to find, did I get the right value here? Yeah, I did. You also could have done this as a z-value. You could have just done z equals 2 minus z equals 0.5, and that would have also worked. And you wouldn't have had to do any halving. Let's see, let me just answer C real quick. Find the value that defines the 75th percentile. Now, a percentile is when you find a point of which, say in this case, 75% of your data is below that value. So for instance, when I say that my son's head is in the 99th percentile, that means his head is bigger than 99% of all other children his age, right? And when I say it simultaneously, his body was at like the 5th percentile, that means his body was smaller than 95% of the kids his age, or it was only bigger than 5% of the kids his age, right? And when you consider both of those facts simultaneously in one human being, proportionally, that's a very big head, right? So if I'm talking about percentiles, I'm interested in z-values is what we're considering. So I want to figure out when do I have a z-value of 95%. So z-value, this would have been that 1.64 standard deviations, okay? But that's not in units, that's in standard deviations. So I would have had to take that for part C. I might be able to snug it right in there. I would take the mean, the 140, and add that z-value times the standard deviation. Okay, so 1.64? Yep. Oh, 75%. Thank you. Yeah, I see what you're saying now. Yeah, so the z-value is 0.674. That was just no 1. So 0.674. Man, short-term memory here. And I'd multiply that. That's in standard deviation, so I'd have to multiply by what a standard deviation is in order to figure that out. And if I calculate this all out, so 0.674 times 20, that's 13.48 units that I'm adding to 140. So that would be 153.48 units. All right, and that is your 75th percentile marker. That means that from 153, right, this is the point where 75% of the data is less than that. Right, so that's the idea of a percentile. Well, anyways, thanks for watching, internet friends. Have a great day. Have a normally distributed day. Bye-bye.